This is a movie on entropy balance with mathematical modeling minds. This session presents a discussion on entropy. What is entropy? Some definitions of entropy, entropy balance, and how to apply the energy balance for different process equipment. First, let's see what is entropy. It is the nature of the universe to proceed in the direction of randomness. Entropy is a measure of this randomness or the disorder of a system, and it is used to address the inefficiencies. Higher the entropy, higher the disorder of the system, and it leads to reduced capability of performing useful work. Irreversible processes generate entropy, and hence the entropy of the universe increases. The reversible processes generate no entropy, and hence the entropy of the universe does not increase. Impossible processes result in negative entropy generation. In the microscopic definition of entropy, it is measured as a molecular disorder of the system. This can be occurred due to physical arrangement of atoms and due to the distribution of kinetic energies of the particles. What is macroscopic entropy? Specific entropy is a state variable of the system. It is an intensive property. Differential entropy change of a closed simple system is equal to the heat absorbed by the system along a reversible path divided by the absolute temperature of the system at the surface where the heat is transferred. A closed simple system is a system that has no internal temperature gradients, no composition gradients, no internal rigid adiabatic or impermeable walls. When the system changes its state from 1 to 2, the entropy change can be estimated by integrating this equation. But you should always remember that this integral should be evaluated along a reversible pathway. If the path from state 1 to 2 is reversible, then use that path. If the path is irreversible, then consider any reversible path. Now let's move on to the entropy balance. Entropy change within a system boundary is equal to the difference between entropy transported in and out of the system plus the entropy changes due to the heat flow across the system boundaries plus the entropy generation. So, this is the general entropy balance for a system. For a steady-state system, there is no accumulation of entropy, and ds by dt term goes to 0. For a closed system, there is no mass flow, and the entropy associated with mass flow rates goes to 0. Now we can have a look at how this entropy balance is applied to different process equipment. Consider a shell and tube heat exchanger with only 2 streams and assume that the heat exchanger is at steady state. So, there is no accumulation term and mdot in will be same as mdot out. If we apply the entropy balance for the entire heat exchanger, there is no heat transfer to or from the surroundings other than heat losses. We can assume that Qdot is equal to 0. If we know the inlet and outlet streams of the heat exchanger, we can calculate the entropy generation for that heat exchanger. Heat exchangers are irreversible equipment because there are finite temperature driving forces across the walls. Reversible processes are the result of infinitesimal driving forces. So, heat exchanger is not a reversible process. Entropy balance for a turbine. Turbines that are operating under steady state and adiabatic conditions have the same entropy balance as heat exchangers. But if the turbine operates reversibly, entropy generation S dot gen will be 0 and inlet entropy is equal to outlet entropy. Compressors and pumps follow the same entropy balance as turbines. Entropy balance for throttling valves. Steady state and adiabatic throttling valve has an entropy generation. They are irreversible because of the pressure drop through the valve and hence entropy of the output stream is greater than the entropy of inlet stream. Entropy balance for nozzles. Nozzles are operating under steady state, adiabatic and nearly reversible conditions. Therefore, inlet entropy is equal to the outlet entropy. This is the end of this video. If you really like the video, give thumbs up and subscribe for the channel and press the bell icon for new video notifications. Thank you.